All right, 9.5. All right, so we are going to talk about series. So we're going to add up all the numbers in the sequence. And there are two series that we want to talk about. The first one is arithmetic series, which is the sum of arithmetic sequence. And the geometric series is the sum of geometric sequence. When you get to calculus, there's going to be more series than just these two. But for now, we're going to just focus on these two. All right. So let's look at A. 1, 2, 3, 4, add all the way up to 80. So talk to your partner. What kind of series is this going to be? Arithmetic or geometric? You and Andy can talk to each other. Both of you are like, my invisible partner. Okay, how many people think it's arithmetic? Raise your hand. Okay, overwhelmingly so. Very good. So the question is, how many terms are there? 80. Good. Okay, so we're going to add up 80 numbers. Now, because it's a arithmetic series and you don't want to punch into your calculator 80 numbers, there is a formula, and we don't have time to derive the formula, but if you look at last year's notes or the book has some stuff, they can show you how to derive that. But the sum of n numbers, if it's just going up by a constant term, is n divided by 2 times first number plus last number. Okay, it's a very well-known formula.
So it's the 80 terms of, and it's 80.
Okay, so this one, sum of 80 numbers is 80 divided by 2 times. What's the first number? 1. What's the last number? 80. Okay, so this is going to be 40 times 81. $3,240. Yes. All right. Let's look at another one. This one. Oh, this number is wrong. It should be 5. Okay, if it's 3, you can't solve it, so it actually doesn't work. Okay, what kind of series will this be? Arithmetic. So what number are you adding or subtracting everything? 7, very good. So subtracting 7. What term number is 5? How many numbers are there? Huh?
56.
No. Huh? 17. How do you know that? Okay, here's the trick. You don't know what this is, but you know this is AN. Remember, AN has a formula, the explicit formula from the arithmetic sequence. It's, if you recall from yesterday, A1 plus D times M minus 1. I don't know what term number 5 is, but I know the number is 5. So 5 goes in here. 117 goes into A1. I know I'm going to subtract 7 every time. I just need to find N. Okay, this is the fastest way. Of course, you don't have to do it this way because you could take 117 minus 5 and then divide by negative 7. And right, yeah. That's exactly what you're doing with that formula. Anyways, so find N. 17. 17. So this is going to be, we didn't know what it was, so we wrote AN, but it's actually A17. Okay, so now use the formula to find the sum of 17 numbers. Okay, so the sum of 17 numbers is 1037.
Odd number.
If it's an odd number?
Because the n is odd, so if you divide 17 by 2, you get a decimal.
It will always work out. It doesn't really matter because the formula has a reason that it works, right? Okay, let me, show how to do it? Okay, 17 divided by 2 times first number plus last number. Okay, now let me ask you a question. What if you saw a number like this? You did your work and you got this. Yeah, does that make sense?
No.
Why not?
Oh, because the numbers are positive.
Yeah, all the numbers you're trying to add are positive. You cannot get a negative number. So this is kind of like, oh, something is wrong. Why am I getting this number? Or you got something like this. Would that make sense? No. Right? Because you're adding up integers, all of a sudden you get a decimal. That makes no sense. Right? So you have to ask yourself, does my answer look right? Instead of just, I got an answer on my calculator, that must be right. Yes? Then no, it's not. Is it possible? Yeah, is it possible? No, it's not possible because you're adding up all positive numbers. You shouldn't get a negative number. If you did, you put something wrong in your...
Negative numbers.
If you add up all the negative numbers, then you should get a negative number. You should not get a positive number. Okay, let's try another one. Okay, arithmetic or geometric? Oh, you guys are fast. What is the ratio? 3. Okay, let me give you the formula. Because we have to figure out what term number this is. Yeah, it's a little bit crazy. All right, geometric. There are 2 kinds of sum. One, finite, meaning the series ends. This is a1 times 1 minus r to the n over 1 minus r. This formula is a... Oh, definitely, yes. Yeah, it's in the Schoology thing I gave you. This formula is on there. Okay, so this is a finite series, means that there is a finite number of terms. The next one is infinite series. If it's an infinite series, we have to check first, does it converge? It converges if the ratio, the absolute value of the ratio is less than 1. That means the number is getting smaller. Then the infinite sum is going to be a1 over 1 minus r. All right. If you don't like to remember both of these formula, you can just remember this one because when n is really large, n is infinity, so then you put infinity in here, it becomes this one. But that is a lot of work to think about. So anyways, just memorize both formulas. All right, so let's look at this one. R is 3. The question is, what is this n number? How many terms are there? This one is a little hard to do. Eventually, yes. So what we want to do is probably start with your explicit formula again. So explicit formula is a1 times r to the n minus 1. Hopefully you remember that from homework last night. So 98415 equals 5 times 3 to the n minus 1. Okay, what should we do to solve this for n? Divide by 5. Divide by 5, we get 19685 equals 3 to the n minus 1. Okay, at this time, what should we do to get n down? Or how do you want to solve it?
Log.
Oh, very good. Log. Because I don't know what is 19685 as a base of 3. I cannot figure that out. So I'm going to bring that n minus 1 down. Okay, this is where you have to be careful because it's a log of something. Now you're going to get into decimal numbers and you don't want to round. So what you want to do is actually just use your calculator. So you might want to simplify all the way. Add 1, right? So that's n. You might want to type that whole thing into your calculator. That way you don't round. If you start rounding, your n might end up having decimals. You might end up having like 8.9999999. And then you're like, does this mean 9 or does it mean 8.999? So you don't want that to happen. Type that whole thing in your calculator and get an n value. What? Are you sure?
Yeah. Yeah.
Are you sure? Let me see.
Where's my calculation?
Unless I put something 98415 divided by 5. Oh, I'm sorry. I wrote the wrong number.
Oh, definitely not.
Darn it. It says 3. Sorry. Oh, that's why it didn't work.
I don't know what's happening.
Sorry, it's 19683. I put 5, but it's actually 3. Sorry about that. That's why it didn't work. Does it work now?
Yeah.
Okay, what is n?
10.
Good. Okay, so now we want the sum of 10 numbers. Okay. A1 is 5 times 1 minus r to the 10th over 1 minus r. Okay, this is, yeah. Okay, I'll come over. So this one is a lot to type in, so please be careful. Again, what kind of numbers are you supposed to get? If you add up all the numbers. Whole numbers, yeah, integers. Okay, so you should get integers. If you start getting decimals or negative numbers, you know something is wrong because you're adding up all positive numbers. Right? They're all positive. You should still get positive. Okay, all right, go ahead and try it. All right, what numbers did you guys get for the sum? Good. All right, let's have you guys try the last one. This one's a little bit tricky to see. Okay, what do you guys think? Arithmetic or geometric? Yeah, definitely geometric. So you have to figure out how many term numbers and figure out the sum. Okay, let's make sure you understand. This last part is all an, not just this part, okay? Some of you just put that part, and that's not what it is. It's 42 times that whole thing. That's last number. That's the last number. Okay, so explicit formula would be 42 times negative 1/6 to the n minus 1, which is equal to 42 times negative 1/6 to the 9. Everything looks exactly the same except this part, so then you just make them equal to each other. So n is 10. All right, sum of 10 numbers, 42 times 1 minus the ratio to the nth term, 1 minus the ratio. Okay, so make sure you do multiply this or solve that part first before you do 1 minus that. So the answer is about 36. All right, let's really quickly get into infinite series. So far we've been only talking about finite, so we have a limited number of things we want to add. What happens if we make this never end? Okay? So we're going to skip the first one. The first one is just example from last year. Okay, infinite series. So infinite series means what happens when n goes to infinity. There are two possibilities. One is that it will converge to a number, meaning that if you try to add up all the numbers, it becomes just one number. The other possibility is it will diverge. Diverge means that it just becomes, there's no definite sum. There's no definite number. Whether that means infinity, negative infinity, or it just keeps going back and forth between some numbers. So those are the situation where you're going to diverge. Okay. All right, so geometric series converges when absolute value of r is less than 1. Do you guys want to know why, or you just want to know the formula?
Oh, because it's like fraction.
Yes, okay, so why does it converge when r is less than 1? Because it keeps getting smaller. If you multiply a number by a fraction that is smaller than 1, it will just become smaller and smaller and smaller and smaller. Right, until it gets to almost 0. If that ratio is greater than or equal to 1, obviously if the ratio is 1, it just keeps repeating, right? And then when you add up all the numbers, it will just be super big, right? Or if that ratio is bigger than 1, so let's say 2, then it will just become bigger and bigger and bigger, and then eventually it will explode. So it will always diverge if that ratio is bigger than 1. It's an absolute value, so it doesn't matter. But if it's negative, for example, if it's negative 1/2,
It will be back and forth.
it will, but eventually it will become a number.
Oh.
It's just really small. Yeah. Okay? All right. What about arithmetic series? Will it ever converge? What do you guys think? Arithmetic series, will it ever converge? No, why not? Yeah, you keep adding, so it has to get bigger, whether more positive or more negative. So arithmetic series, it will always diverge. So we never talk about the infinite. Yeah.
So if like there's a setting of numbers, it's just like all the same, like 2, 2, 2, 2, is it arithmetic or geometric?
That's a great question. I guess it could be both. All right, let's look at some examples. Find the sum of the infinite series. Okay, talk to your partner. If you add up all the numbers until it gets to infinite number of terms, what does this become? Okay, maybe a better question is, does this converge or diverge? How many people think converge? How many people think diverge? How many people don't know? Converge means the numbers keep getting smaller and smaller and smaller. Eventually, you're adding something like a 0. So does it converge or diverge? Converge, definitely converges. So if it converge, we're going to calculate the sum. First of all, what is r? 1/10, 0.1, yes. That number is smaller than 1, right? So definitely converges. It's the sum of infinite number of terms, so we're going to use this formula. So this is going to be a1 over 1 minus r. So that is 0.1 over 0.9, 1/9. So if you add up all the numbers, you will get 0.111111111 forever, right? Which is the same as 1/9. How about this one? 10 plus 20 plus 30 plus 40. Yes, very good. Diverge. It becomes super big. This last one is tricky. Converge or diverge? How many people think converge? How many people think diverge?
Oh, diverge.
Yes, it does diverge. Why?
You go back and forth between
Between what?
1 and 1.
1 and 0. 1 and 0. It oscillates between 1 and 0, 1 and 0, 1 and 0, so this diverges. There's no definite sum.